Hello all, I am Dr. Pravas. In today's class, we will discuss about the code generation. So here, the code generation is the last phase of the compiler or sixth phase. The sixth phase or last phase of the compiler or last phase of the compiler. In general, what happens in code generation phase? We just generate the assembly language. We just generate the assembly language code, or we can say target program. Okay, target program. We just generate the assembly language code for the given three address code. Okay, so see, this is one of my three address code. Will generate the assembly language. How to generate? Just see here, the first statement what? T1 equals to A plus B, means T1 contains A plus B. That means first we'll store A value in one register like R0. So I'll store this A in R0. That means we'll use move operation. Move A comma R0. Move A comma R0. That means we'll move or we'll store A in R0. Then what? We'll add this B with A. That means we'll add what? B with A. But A is stored in which register? R0. That means now we'll add A plus, sorry, we'll add B with A. Now R0 stores what? A plus B value. So that means add B with A R0, because initially R0 contains which register? A. Suppose for example, my A value is 5, B value is 7. Here R0 initially contains what? Which value? Move A in R0, that means A value means 5. Okay. Then add B. B means 7. 7 with R0, but R0 contains 5. So 5 plus 7 equals to 12. In this way, we will perform. Okay. Let this value is T1. Let this value is T1. Because we will store the A plus B in which temporary variable? T1. Then we will perform C minus D. Similarly, we will use one more register, what? R1. So we will store C in R1. So move what? C in R1. Then subtract SUB, subtract D from R1. This is which variable? Temporary variable. This is for T2. Okay. So then we'll move this E. We'll move E in R2. We'll move E in R2. Then we'll perform division operation. DIV, division operation, division F comma R2. This value means it is T3. Okay. Then just see, T1 means which variable? R0. T2 means R1. Then we'll perform which operation? Multiplication operation. So MUL, multiplication T1 into T2. T1 means R0 register. T2 means R1 register. Okay. So this is nothing but T4. Okay. Then we again will perform multiplication operation. T3, T1. T3 means R2 register, comma T1. T1 means R0 register. So it is nothing but T5. Then we'll perform multiplication operation. T4. T4 is nothing but R1. T5. T5 is nothing but R0. Okay. Then we'll multiply T4, T5. So then we'll move. Multiply, just say multiply T Okay, we'll multiply T4 and T5, but we'll store the multiplication value in which register? R0. So we'll move what? R0 in X, in X. Okay, so in this way we'll generate the assembly language. Okay, I again explain once more. First we'll move A in R0, then we'll add B with R0. B R0 means finally the addition value will store in R0. Means R0 contains A plus B. Here R0 contains what? A plus B. Now, so we'll move C value in R1, then we'll subtract D from R1, D from R1. That means R1 contains C minus D. Then we'll move E in R2, then we'll perform division F with R2. So finally R2 contains the division of between A, E and F. Okay. Now, then we'll perform the multiplication operation T1 between T2, T1. T1 means R0, T2 means R1. So multiplication R0, R1. So we'll perform T1 value and T2. So finally we'll store means R1. Finally we'll store the multiplication. That means we'll store T1. Means R0 contains what? T1, T2. T1, T2 means we can write here what? T1 means A plus B multiplication T1, T2. T2 means what? C minus D. Okay. Finally R0 contains. Then we'll perform multiplication T3, T1. T3 means the division. The division what? T3 means what? The division operation means E by F between T1. T1 means what? Let's see. R0. R0 contains which value? This value. What? A plus B into C minus D. Finally, R2 contains means R1 contains like this. Okay. Then we'll perform the multiplication again. Means R1. R1 contains which value? This one. R0. R0 contains which value? This one. We'll again multiply this one with this one. It will store in where? R0. Finally, we'll store means finally R0 contains the multiplication of this value and this value. Then we'll move what? This R0 value means this R0 value in X. In this way, we can generate the assembly language. Remember one thing, move one operation is, one assembly language like move, load, store. All meanings are same. All meanings are same. Suppose move A comma R0. Remember, move A comma R0. That means what? That means R0 contains, let R0 contains A value. Let R0 contains A value. So if we will use move, so what move? That means move A comma R0 represent R0 of A. Means R0 register contains A value. Suppose load this A value. Suppose load or store R0 comma A. Okay, load R0 comma A. That means both meanings are also same. Means when we will perform load, that means A will load in R0. But move always means always runs from, we can say, left to right. But here load is always load or store, we can write also same R0 comma A, also both are means it always moves from right to left, load or store operation. But move operation always performs means from or it moves from left to right. Okay, in this way we can use or we can generate the assembly language, but all meanings are same. Sometimes you can say load or store operation. Okay, load a in R0, store a in R0, but here move always moves from left to right. But in case of load and store, always it moves from right to left, but all meanings are same. Either you can use move or we can use load or store. It's not a problem. Okay, thanks for watching.